Hey guys, tonight we're going to start order of operations. This is video lesson 2-3. Our learning goal for tonight is I can evaluate equations with variables using order of operations. This is going to be our learning goal for a couple of days. We're not going to get into variables tonight. We are in the next couple of days, but not tonight. But I went ahead and used that learning goal that's going to be kind of overarching for several days. So our vocabulary is order of operations, is the order in which to perform operations and calculations. A 2, which it should be, is evaluate, which means basically to solve an equation. And the third one is exponent, the number that a number is to be raised. So go ahead and stop and write these in your journal, your learning goal in your vocabulary, and then we're going to go ahead and look at some steps of order of operations. All right, what is order of operations? Now that Thanksgiving is over, I know I did a lot of cooking and your family might have done so. So I'm going to use this as an example of, have you ever cooked something that came from a recipe? And did it list the ingredients that you needed? And what else did it show you? And if you said that it told you how to mix the ingredients and in what order, you're right. Is it okay to leave out important ingredients? Why or why not? Will you get the same product in the end? I want you to stop the recording and just jot down a couple thoughts about this. For example, if you're looking at a recipe and you decide, hey, I'm going to leave this out, or I'm going to add this ingredient even though it's not written on the recipe, am I going to get the same product in the end? Am I even going to want to eat it? Okay. And why or why not is it okay for us to add something or take away something from a recipe? When it comes to order of operations, we know that there's only one correct answer. So a recipe is going to give you one really, really good, whatever cooked product, a good pie, okay, a good recipe, a good cake, a good turkey. So a recipe tells you what to put in the food, what order to mix the ingredients, and how long to cook it. So order of operations really does the same thing. We're going to use PEMDAS quite a bit, and here in the next couple days I'm going to give you another acronym. I'm not going to get into that tonight. But when we evaluate equations with exponents, variables, parentheses, and the 4 operations, there's one order that we can follow. And we will not have the correct answer if we don't follow the quote recipe. So the PEMDAS stands for P for parentheses, so you do everything inside of those first. Exponents is you will solve any exponents in your problem. Multiply and divide, always moving left to right. No matter which multiply or divide comes first, you're always going to do left to right. And adding and subtracting, you will always go left to right as well. Those 2 bottom ones get a little bit tricky because we think in PEMDAS, oh, we have to add before we subtract. Well, even if there was subtract before add, we would still move left to right. So those, I think, are the 2 trickiest things that we come across when we do PEMDAS. So we're going to try really hard not to get messed up on that. And so we're really going to concentrate on that in class. So the rules of PEMDAS, of course I have some non-negotiables as I call them, is you are going to do one thing at a time. So one operation at a time. So for those of you that are those math brains that can do all of that math in your head are going to be frustrated at me. But this is non-negotiable, and I'm going to make you do one thing at a time, because as we get further down the road and as you start pre-algebra, even next year, your problems are going to be much more difficult, and you're going to confuse yourself by trying to do several things in your head at one time, and we always have to show our work. We all know that's a non-negotiable as well. Secondly, underline the part that you're solving. That is going to help you know what you've already dealt with. Third, bring down the problem each step. So every single time, bring down the rest of the problem. And then your problem is really going to look like an upside down triangle or a piece of pizza, if we're talking food, because I like pizza. So your problem is going to look like a pizza with your answer being at the very bottom. Here's an example that I gave you. In parentheses, 37 plus 12, parentheses, minus 5 times 3 to the 2nd power. Notice that the asterisk, or the star you might call it, means multiply. So we've talked a little bit about how we're not using the multiplication sign when we're outside of parentheses because that could look like the variable. So that asterisk actually means multiply. So that might be a little new to you. I brought down 37 plus 12, and I couldn't get this to underline, so we would if we had paper. And 37 plus 12 is 49. And then I brought everything else down. Minus 5 times 3 to the second power. Now I see I have an exponent. So please, 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 please remember that 3 to the second power is not 6. It is not 3 times 2. The 2 is kind of bossing the 3 around, is what we're calling it. The 2 is telling us that we need to take 3 times itself 2 times. So that's where I got the 9. So it's 3 times 3. So 49 minus 5 times 9. So I am left with subtraction and multiplication. So in PEMDAS, multiplication comes before subtraction. So 5 times 9, I brought down 45. And then I brought down my 49. So I'm left with one problem, 49 minus 45. And then my answer is 2. So what was the first part that I solved? Why didn't I subtract 5 from 49, it should be, before multiplying by 9? And do you see my pizza, my upside down triangle? That's what yours are going to look like every single time.